Hello and welcome lads and lasses to another video. My name is Tammy Chowdhury, the only doctor without a PhD. Yes, I've been off for a week. It's because I just finished my level 2 exam, thank God. But the tuition had to screw me over and I have to do another IGCSE exam in 4 months time. So yes, my life is pretty crowded right now, but at least I got to manage to fit in a video today. And my nose is kind of blocked because it's very hot outside and I never knew I'm gonna have like some reaction to this chemistry.
Oh, for God's sake.
So let's start with the video. So what are compounds? Compounds are two or more elements, which in the previous video, elements are substances that only contain one type of atom that is consistent throughout. If you need to watch a video on atoms and elements that I made, the link is going to be in the description below. And yeah, so compounds are two or more elements that are chemically bonded together. Now the chemical bonds formed between these compounds are mainly from the interaction of electrons. So if we look at ionic compounds, which is mainly compounds that involve a metal and a non-metal, the electrons are transferred from the metal to the non-metal. So the metals form positive ions, the non-metals form negative ions because they're gaining electrons, the non-metals, and the metals become positive because they're losing the electrons. And the electrostatic forces between those two ions, so positive and negative, attract, so it forms a bond forming an ionic compound. They can be also covalent compounds where they form covalent bonds, which is normally non-metals where they share electrons, so there's a very strong covalent bond between the two atoms from covalent bonds, covalent compounds, as I said. Yeah, now the atoms in these compounds are in fixed proportions. Before I was interrupted, atoms are in fixed proportions in compounds. So let's say we have a compound called carbon dioxide, which is CO2. Now, for every one carbon atom, there is 2 oxygen atoms. So no matter, so you can't change the numbers in the bottom. So like, if I get the whiteboard, CO2. Yeah, you can't add numbers here. You can't change this number because you're basically changing the compound. So if I remove this one here, it will become carbon monoxide and all that. So if I add a number right here, so let's say a 2 or a 3, then there's going to be, so if I put a 2 here, there's going to be 2 carbon atoms and 4 oxygen atoms, so there's still a 1:2 ratio in it. But if you're mathematical, you might try simplifying these atoms, but there's no point. You don't want to change the whole element. Now some common compounds you might want to look out for is hydrochloric acid, sodium chloride, what else is there? Ammonia, sulfuric acid. These compounds you don't need to usually know, but it's better to know for the exam, even though they do give more, mainly the chemical equation for it. Now let's look at chemical equations. Now chemical equations, you see them everywhere, like let's say Mg plus O leads to MgO and all that, and also you have to balance it. And yeah, so in your GCSE chemistry exams you will get equations and you will need to balance them. Sometimes they can range from 2 to 4 marks, and sometimes they can be hard for some marks because you might not know the right method, but don't worry, I'm teaching you this. So let's start with a relatively simple chemical equation so I can teach you guys how to do it. So behind me I got a chemical equation. We got H2SO4 with sulfuric acid plus sodium hydroxide. These two
Nice.
whatever that element is, because compound I mean, plus water. So you might want to do the long method. Some people can just see it in front of their eyes, but it's better to do like just labeling. So here, what I would do, so what I'll do here is just, I'm gonna mess up the line, but whatever. So I'm gonna write out the elements of this side. So there's hydrogen, there's sulfur, there's oxygen, there's sodium, and then obviously there's gonna be, I'm gonna just draw a direct line here. There's gonna be sodium, there's gonna be sulfur, there's gonna be oxygen, there's gonna be hydrogen. So yeah, so I'm gonna just state the number in each of these equations. So there's 2 hydrogen there, another hydrogen there, so that's gonna be 2 plus 1, which is 3. There's 1 sulfur here, no other sulfur in this part of the reaction, which is just 1. There's 4 oxygen plus 1 oxygen, that's just going to be 5 oxygen, and there's 1 sodium. Now I'm going to go to this side and just state my values as well. So there's 2 sodium right there, there's 1 sodium right there, there's 5 oxygen right there, and 2 hydrogen right there. Now let me look at why I don't have balance. So sodium is unbalanced, so I'll just put a 2 right here. So that will change into a 2, but then everything else changes. So this oxygen here is being times by the 2 as well. So this is going to be 2 plus 4, that's going to be 6, because 4, and then there's 2, so there's 6. The hydrogen is going to be 2 plus 2, which is 4. Now let's see what we don't have balance. We don't have the hydrogen balance and we don't have the oxygen balance. Everything else is balanced. So we just look at, well, how can we times this to get to 4? We just times by 2, and everything else we balance, so that's going to be 4. 2 plus 4 is 6, yeah, and that's balanced. So the final balanced equation will be H2SO4 plus 2NaOH leads to Na2SO4 plus 2H2O. That's a mouthful. Here we got a bit more of a harder question. So CaCO2 plus Na3PO4 leads to Ca3 brackets PO4 brackets 2 plus NaCO. Now one thing to understand here is what these brackets mean. So in maths is basically, in maths you might follow the rule, whatever is outside the bracket you times it with inside the bracket. So if you, for example, you got 2x plus 2, for example, you times the 2 with x, 2 with 4, so you get 2x plus 4 basically. So yeah, so if you look at here, we will basically have, let me actually just label out what I have. So I'll go to this side again. So I got Ca, I got Cl, I got Na, I got phosphorus, I got oxygen. Just put the equal signs right there. I'll have the same here, so I got Ca, Cl, Na, P, O. And yeah, so now I will just state what values I have in this equation. So basically, let me just zoom in a bit so it's just easier to see. There we go. So calcium only have 1, chlorine only have 2, sodium only have 3, phosphorus only have 1, oxygen only have 4. Alright, that side is done. I labeled all my values there. Now I'll go to this side. Calcium I have 3, chlorine I have 1, sodium I have 1, phosphorus I have that, so there's 1 here times 2, so there's 2. Oxygen, 4 times 2, I have 8 oxygen right there. Now, one thing to bear in mind, always do this in pencil because you're going to be crossing out and all that, because your first try might not always be successful. So let's firstly see what we've got here. So our calcium is not balanced, so to get to 1, 2, 3, we'll times this by 3. So that'll be 3, 2 times 3, that'll be 6 chlorine already. Now, the sodium is not balanced, so I'll just put a 3 right here. So that'll be a 3, and the chlorine will turn into a 3. The phosphorus is also not balanced, so I'll just put a 2 here. So the sodium will be 6, the phosphorus will be 2, the oxygen will be 8. So the oxygen and the other oxygen is balanced, the phosphorus and the other phosphorus is balanced. The calcium and the other calcium is balanced. The only thing here is the chlorine and the sodium. And obviously we can see there's a scale. This looks so messy, but I can't be asked to do anything else. So to get from 3 to 6, obviously just times it by 2. So we just need to do 3 times 2, which is going to be a 6, and that's balanced. So let's see what we got. 3 calcium, 6 chlorine, 6 chlorine, 6 sodium, 6 sodium. Oh crap. 2 phosphorus, 8 oxygen, 8 oxygen. That's done. We just balanced this equation. Now let me just go read you one more and then the video is done. Now here this is going to be a question where I'm going to be teaching you a quicker technique with questions you might come across with this. So obviously name our values. So we got arsenic, sodium, oxygen, and hydrogen. So we got 1 arsenic here, we got 1 sodium there, 1, just 1 everywhere. And then we got, let me just line them up so it's way better. So we got arsenic, sodium, oxygen, and hydrogen. We got 1 arsenic, 3 sodium, 3 oxygen, 2 hydrogen. Alright, so now I will just see, okay, the arsenic is balanced, the sodium is not balanced, so I'll just put a 3 right here. So that will be changed into a 3, that will change into a 3 as well, and that will change into a 3. Now, one quick way to do this, so we see the hydrogen and the other hydrogen is not balanced. But then we're gonna if we keep doing this, if we wanna quickly balance it, let me retract my statement. So essentially what we'll do here, so basically if you're gonna just keep finding out, okay, I'll just put, so 3 and 2, the common multiple is 6, I'll just put a 3 right there, a 6 right there, sodium's not balanced. You'll just keep changing your values for each one of those. So one way to do this is I want to do 3 divided by 2. So what times by 2 can what can 2 be times by to get 3? Now what 2 can be times by to get 3 is 1.5. So we'll put 1.5 there. But we're not done yet, because you can't have 1.5 moles in chemistry. It just doesn't work out. So let me just rub this out here. So you might get baffled at what I'm gonna do next, but since 1.5 is a whole number, and to get 1.5 into a whole number, you have to times by 2 to get 3, which is a whole number. I can't just times this by 2 itself. It doesn't work. I need to make sure everything is the same. So I'll times the whole thing by 2. So if I times the whole thing by 2, you'll get 2AS plus 3 times 3 is 6 NaOH, and then 2 Na3ASO3 plus 3H2. Now that is a balanced equation right there. Let me just make sure that's a 2. Now, just so I can clarify why I times it by 2. So 1.5 mole, I have 1.5 moles of hydrogen right there. In chemistry, you cannot have 1.5 moles. I don't know about A level if they accept this, but GCSE definitely do not accept 1.5 moles. The only way you can times it by 2 is when everything else is balanced, but only one element is not balanced. So here, everything else was balanced apart from the hydrogens. So what I could have done is just find out the multiple from hydrogen that fits into that, which was 3 back in that. So 3 hydrogen, there was 2 hydrogen there. So times by 1.5 to get 3 hydrogen, 1.5 times 2 is 3. So then I have to times this by 2, because obviously you get to a whole number there. And then and then you have to times everything by 2, because how do I explain it? It's like in maths where, let's say I have like an inequality. So let's say I have 15 leads to 3x leads to 6. Now if I want to get x on its own, I have to divide every side by 3, so it just stays like uniform in that. So that would be 5 is less than x is less than 2. It's the same concept applied in chemistry. Now this is why I like these type of things, because obviously maths is involved, and of course it does require a bit of thinking and with chemistry equations and that. So yeah, this is a common way to balance this. And to check if it's balanced, 2 arsenic, 6 sodium, 6 sodium, 6 oxygen, 6 oxygen, 6 hydrogen, 6 hydrogen. There, it's done on the wall balance. Thank you guys for watching this video. Hopefully I'll see you next time.